Alright, today we're going to talk about logarithms again. The only difference being we're going to look at logarithms that have e as their base. E is a constant. It's approximately 2.7. We call these kinds of logarithms natural logs. All the same properties that you used in the previous lessons you'll be able to use here. For example, if you have a coefficient like this 3 here, you can move it and it becomes your exponent. Same thing with this other. So if you were to rewrite this as a single logarithm, this would be the ln of 2 to the third. Minus turns into division over x to the third. Take it a step further and write 2 to the third as 8. Your answer is the ln of 8 over x cubed. For part B, you have another coefficient, so move that to your exponent. That becomes 3 to the second power. Plus gets rewritten as multiplication. So this is going to become the ln of 9 times 8, which is the ln of 72. Part C, all three parts have coefficients, so all of those become exponents. So you've got the ln of x to the 20th, plus becomes multiplication, multiplication by y to the 5th, and minus turns into division. So z to the second goes below the fraction line. So there's your answer. Next thing we're going to look at is solving equations. We're going to look at ones that contain logarithms at the beginning. So if you have ln in your equation, you're going to rewrite into exponential form. Okay, so e is understood to be your base. It's not written, but it's understood to be your subscript. So if you were to rewrite this into exponential form, it would say e to the 5th equals x. If you were to approximate that on your calculator, e to the 5th power is about 148.41. Part B, once again, switch to exponential form. Understood that e is your base, the subscript down here. So in this case we write e to the third equals 6x plus 1. E to the third is approximately 20.09. Take away 1 from both sides. You get 19.09 equals 6x, and then divide the 6 out. So x is approximately 3.18. Part C, you have an exponent this time. Probably the easiest way to solve this would be to move your exponent in front and let it become a coefficient. So then you have the following equation. Before you switch to exponential form, you want to get rid of the 2, so divide it out. Then switch it to exponential form. Remember, it's understood your base is e with the natural log. e to the third equals 2x plus 1. E to the third is approximately 20.09. Take away 1 from both sides. Get 19.09. Divide by 2. And if I punch this up on my calculator, get your approximate answer. X is about 9.55. Example 3, we have equations that start out in exponential form. So what we'll do here is we'll take the logarithm on both sides. Okay, so if you have exponential, you're going to take the logarithm on both sides to start. So it'll look like this. This time we're doing natural log, so we're going to use ln. In this case, ln of e to the x plus 3 equals the ln of 24. Understood that there's an e here, so if we have an e here and an e here, they kind of cancel each other out. So what drops down is just your exponent, x plus 3. It's equal to the ln of 24. And then on your calculator, take the ln of 24 and subtract 3. Make sure that you close the parentheses behind the 24 before you subtract the 3. So x is approximately 0.18. In part B here, you've got another exponential equation. First, before you take the ln of both sides, divide the 5 out. Get rid of the 5. So that leaves you with e to the negative 3x equals 9. Then go ahead and take the ln on both sides. Okay, it's understood that there's an e here, so they do cancel out again. So you drop down your exponent. You've got just negative 3x on the left side of the equal sign. Equals ln of 9. Divide both sides by negative 3 then. So take the ln of 9, divide by negative 3 on your calculator. And you get approximately negative 0.3. The last exponential starts out like this. You have two numbers around the exponential to get rid of. So if you have minus 8, you want to add 8 to both sides. Divide the 2 out. It says e to the 5x equals 19. Then once again, take the ln on both sides. The e's cancel out, and you drop down your exponent, which is 5x in this case. 5x equals the ln of 19. Divide both sides by 5. Take the ln of 19, divide by 5, and you come up with, let's see, approximately 0.59. The last thing we're going to look at here is an application for natural logarithms. One of the applications you might see this show up is with estimating the age of fossils. Using this formula here, if you're given a fossil's carbon-14 percentage, you can substitute that into the formula and get an approximate age for the fossil. So NF, N sub F divided by N sub 0 represents the percent of carbon-14 remaining in the fossil. So in this case it's 30%. So you have to write that as a decimal first. So write that as 0.3. Put in your denominator. So on your calculator, if you take the ln of 0.3, divide by negative 0.693, and then take that number and multiply it by 5,700, you get an approximate age of 9,903 years.